section of notes covers Trig, Chapter 5, Section 4. We're going to be dealing with solving exponential and log equations. So the thing we're going to have to be able to identify is whether we have a exponential equation, like these two examples over here, or whether we're in log world and we have log equations. There's really going to be 4 different types of problems that we can solve. So I'm going to show you an example of all 4. And then we'll go through and we'll decide which one of these methods we're using to solve. So let's first talk in exponent world. There's 2 ways we can solve these problems. We can choose to make the bases be the same, or we can, and if we can't do that, like for this second example here, then what we do is we will apply logs to both sides. So let's take a look at those first. Looking at this problem here, that 4 raised to the x plus 2 is equal to 64. I know that 4 and 64 can both be written as base 4. 4 is already done. I know 64 is 4 to the third. So this would give me 4x plus 2 equals 4x to the third. Because the bases are the same, now I can set the exponents equal to each other. So x plus 2 would equal 3, and I would find that x would be equal to 1. Plug that back in and check it. When I put a 1 in for this x, is 4 raised to the 1 plus 2, or 4 to the third power, 64? Yes. Now when I can't set the bases equal to each other, this is a base 2, this is a base 7, there's no way that I can set the bases equal to each other, then what I do to solve this is I apply logs to both sides. So log of 2 raised to the x equals log of 7. The reason that I'm doing this is so that now I can take this exponent and write it as a coefficient. And we learned that in the last section. So this would become x times the log of 2 equals the log of 7. And now, because it's x times the log of 2, to get rid of the log of 2, we would divide by the log of 2. We would find doing this that x would be equal to 2.807. Now I rounded that answer. But what this is really showing us is that 2 raised to the 2.807 is approximately 7. So that's how you would go back and check this answer to make sure that it works. So you either make the bases the same, or you can't make the bases the same, so you apply logs to both sides. In log world, you're going to see 2 different types of equations: a log equal to a log, or a log equal to a number. When a log, in this case log base 5, is equal to another log base 5, what will happen is the log base 5s will go away, and you'll be left with, just in this problem, 2x equals 36. We divide by 36 and get 18. So, you notice when I plug an 18 back in here, 2 times 18 is 36. Log base 5 of 36 equals log base 5 of 36. So it checks out. When you have a log equal to a number, the way you solve this is you actually write it out in exponent form. So remember, when we do this, the 6 is the base, the 2 is the exponent. The 6 is the base, 2 is the exponent. Whatever the log is equal to is always the exponent. So writing this out in exponent form, we would say 6 squared equals 4x. So 36 equals 4x. We would divide by 4 to find that x is 9. So let's think about this. If I plug a 9 into here, really what I get when I check it is the log base 6 of 4 times 9 equals 2. Log base 6 of 36 equals 2. Well, is 6 squared 36? Yes, so it checks out. So you're going to have to be able to identify the 4 different types of problems that you're going to see, whether it's an exponent world or log world, and then you'll pick one of these 4 ways to solve your problem. So let's do that now. So looking at this, to solve this one, what we want to do here is recognize that 9 and 1 over 27 can both be written as bases of 3. So we'll start with the easy side. I know that 3 squared is 9, so this side would be 3 squared raised to the x plus 2. Over here, I know that 27 is 3 cubed, but I don't want 27, I want 1 over 27. So I'm going to have to take 3 and raise it to the negative 3 to get 1 over 27. So this side of my problem would be equal to 3 raised to the negative third. Now as I look at the left-hand side of the problem here, I'm going from a power to a power, so the rules for exponents here is that we multiply these together. So we would do 2 times x plus 2, and then over here the exponent is negative 3. So since now they both have bases of 3, we could set the exponents equal to each other. So 2x plus 4 equals negative 3. Get rid of the 4 and divide by 2. So when I do this, I'm getting x to be equal to negative 7/2. I can check that by going back up here in my calculator, typing in 9 raised to the negative 7/2 plus 2. And when I put in negative 7/2 in here, I'm going to get the fraction 1 over 27. Looking at this example, if I'm going to solve this one's a little bit different because my exponent here has a base of e. So that's really what I want to get by itself first. This e raised to the 2x plus 1, I need to isolate that first. So that's what I'm going to do. I'm going to isolate my base, which basically means I have to move over anything that is with it. So I'll move over the 5 by subtracting. You would get 110. Move over the 2 now by dividing, and I get e to the 2x plus 1 equals 55. Now that I've gotten the base by itself, I can apply logs to both sides because I'm not going to be able to make a base of e and a base of 55 the same. Now here, before we apply logs, you have to recognize that because you have an e here, you have to apply the natural log. So because my base is e, I have to apply the natural log because the natural log has a base of e. If this was anything other than an e, I would apply regular logs. Or I could apply natural logs. So the question that usually comes up is, when do I apply natural logs and when do I apply logs? You can always apply natural logs. There's no time that you cannot apply natural logs. But you have to apply natural logs if there is an e. You cannot apply the regular log to this problem. So applying natural logs to both sides would look like this. And now we can write it in exponential form. Not exponential form, sorry. We can take a exponent and write it as a coefficient. So this would become 2x plus 1 times the natural log of e equals the natural log of 55. And then I want to think about this problem for a minute. Take out your calculator and type in into the calculator the natural log of e. What does that equal? Well, you should find when you type it in the calculator that it equals 1. So really what's going to happen in this problem is that because this is 1 right here, I don't really need that anymore. So now my problem is just 2x plus 1 equals the natural log of 55. So to solve that for x, I would subtract 1. I get 2x equals then natural log of 55 minus 1 is 3.007. And again, I rounded that answer, so I want to keep that whole answer in my calculator and then go through and divide by 2. So if I divide that by 2, I end up with 1.504 as my answer to this problem. Take a second to plug this back into your calculator and check it. You'd have to type in 5 plus 2e raised to, and then again make sure that all of this gets put in parentheses. 2 times 1.504 plus 1, you're going to get pretty close to 115. Not exactly, but pretty close, because this is a rounded number. Okay, so our next example, we're dealing with exponent world here. Our base is e. There's the exponent we're trying to solve for, so we need to isolate that. First thing we have to do is get rid of the 50. So minus e raised to the 2x equals 2.5. And again, we're trying to isolate this e here, so I've got to get rid of the 3 by subtracting. So I will end up with negative e to the 2x equals negative 0.5. Got to get rid of this negative here by dividing by negative 1. So e to the 2x is equal to 0.5. Now that I've gotten my base by itself, I can go through now and actually start to work at solving this. So the base is e, the base is 0.5. Can't make them be the same, but what I can do is apply natural logs to both sides. So I have to do natural logs because I have a base of e. Now I can take the natural log, or I can take the exponent, write it as a coefficient. And remember that the natural log of e is the same as 1, so I don't really need that. So now my problem is 2x equals the natural log of 0.5. We divide by 2. So when I do this, I end up getting x to be equal to negative 0.347. Again, that's a rounded answer. I can go up, plug that entire answer in up here, and let my calculator do the work, and I should get 150. This next problem looks very similar to quadratic form, which is ax squared plus bx plus c. In fact, if I just manipulate this just a little bit, if I write it instead as e to the x squared, this would be like my x term squared, minus then 5e to the x, and then plus 6 equals 0, then I can see that I have a term being squared, and then just a term. If e to the x is the same as just x, then this is just 5x, and then plus your number at the end. So if I go through and let's say n represent e to the x, if I replace this with an n, it becomes n squared. If I replace this with an n, it becomes 5n plus 6 equals 0. Now the reason that I've done that is so that now I can look at this and say, I know how to solve this. I factor. I ask myself what multiplies to be 6, but adds to be negative 5. And that's going to end up being negative 3 and negative 2. So this would be n minus 3 and n minus 2 equals 0. So if you set them both equal to 0, you would end up with a positive 3 and a positive 2. Now I'm not done here, because I don't want to know what n is. I want to know what x is. And so I made the substitution here that n was equal to e raised to the x power. So let's go back and change n to e to the x power. So now my problem looks like this. So we've got to think about, how do I solve e to the x power? Well, I apply logs to both sides. In fact, I have to apply the natural log to both sides. Let's do that over here. Natural log of e to the x equals natural log of 2. And then what I can do now is write my coefficient, or my exponent, as a coefficient. And this would be x times the natural log of e equals the natural log of 2. And remember, the natural log of e is the same as 1. So this is really x equals the natural log of 3. The natural log of 3, when I typed it in my calculator, is 1.099. Natural log of 2, when I type that in my calculator, is 0.693. Again, I can go up and I can check this by plugging in my calculator. E raised to the 2 times 1.099 minus 5 e raised to the 1.099. Add 6 to that, I should get something very close to 0. Again, I won't get exactly that because I've rounded here. And then go back through and check with 0.693, again replacing both x's as 0.693, you would find that it would work out. So when you see a problem like this that is very similar to quadratic form, just manipulate the exponents. I can do this because here the rule says raised to a power, you multiply, so it's the same as 2x. So this really is the same as e raised to the 2x. It's just written in a different form that's more user-friendly to be able to solve this problem. And again, I get rid of the e to the x because I can factor this a lot easier than I can factor it when it's in this form.